Hello everybody. Today's lesson is super quick, super easy. You already know how to do part of it. Today we're going to be adding and subtracting polynomials, but before we get started on that, another shout out. Let's see. Julia. Who doesn't miss Julia and her enthusiasm, hard work, dedication to doing well, seeing her every morning in homeroom, writing her passes to everywhere that she's going? Who doesn't miss that? Duck everybody, because she has salad in her hand and she knows how to throw it. So before she throws salad at us, let's get on with this lesson. You're going to learn to add and subtract polynomials. So let's go. So adding polynomials is super easy. You've done it before. It's just combining like terms. And so here we have a problem. There are two different ways of setting up your work. Most of us will do the work like this. Some people do like to see it vertically, so I'll do one example like that. But for this problem, we have this trinomial and this trinomial. We want to add them. These parentheses don't mean anything because all they're doing is separating the two polynomials with an addition sign. So we're going to remove those parentheses and just combine our like terms. So some of you like to separate your terms with either boxes or circle them. Whatever you've done in the past, you can continue to do. So I've separated each of my terms. Remember, the sign goes along for the ride. And now I'm going to, when I write my problems out, I'm going to always look for my highest degree term to write first, because your answer needs to be in standard form. So we want the highest degree term down to the lowest degree term. So I notice that my highest degree term are these x squareds. So altogether I have 16 x squareds. Now I'm looking for my x's. I have a -3 and a +6, so that's positive 3 x's. And then I have a +6 and a -11, so I have -5. So the sum of these two trinomials is this trinomial. It has a degree of 2, it has a leading coefficient of 16, and that's my sum. To see it vertically, I have these two trinomials that are being added. When you set it up vertically, your goal is to line up your terms that have the same variable parts. So there are no x's in this one, so that's why there's nothing above this x, and there's no x fourths in this one, so there's nothing under this. But once you have them lined up, then you just add going down. So if you like this method, you can write out your polynomial addition problems like this. So now I'm adding my x cubes, and I have 7x cubes, and I have 3x to the 4th powers. So this trinomial and this trinomial gave me this polynomial for an answer which has 4 terms in it, and it has a degree of 4 and a leading coefficient of 3. So now we've included 2 practice problems for the addition, and I'm going to use the horizontal method to work both of these ones out, but you can certainly write them vertically if you like to. So these parentheses don't mean anything. So now I'm looking at this polynomial and this polynomial for my highest degree terms. And my highest degree terms are my x to the 5th power. I have -7 and +5. So altogether I have -2x to the 5th powers. Now I'm looking for x to the 4th power, and I have 10 of them. Now I'm looking for x cubes. I don't have any. I don't have any x squareds. So my next higher degree term would be my x's. I have -2 and +7, which would give me +5x. And then my last thing would be my constants, and I have a 14. So the sum of these two polynomials is this polynomial. It has a degree of 5 and a leading coefficient of -2. For my second addition problem, I'm looking at my first term. This has a degree of 7 because it has 3 u's and 4 v's, so this is a degree of 7. a degree of 1. These two are like terms, a 1, and then a 4. So I'm going to start with the degree of 7. I have -5 and -5, which gives me -10 U3V4s. Then my next highest term would be my 4, which would be 8 U2V2s. And then finally I'm going to combine my u's, and I have 9 u's and -8 u's, which would give me 1 u. But I'm not going to write the 1 because it's not necessary. So this trinomial is the sum of these two polynomials. It has a degree of 7 because 3 and 4 is 7, and a leading coefficient of -10. So now we're on to subtraction. Subtraction is just as easy, but you have to do one thing first with subtraction. We turn the subtraction problems into addition problems. And to do that, we need to distribute the subtraction sign as a negative to the second parentheses. So we're distributing this negative to these 3 terms and rewriting it, and then it becomes just a combining like term problem like we've just done. So I'm going to start by writing out my first parentheses, and when I get to my second, I'm distributing the negative as I go along. So I would have -2x cubed, -8, and +4x to the 5th power. Now that I have it written out, I'm just going to combine like terms like we just did. I'm looking for my highest degree terms first, and I have -13x cubed and -2x cubed. So altogether I have -15x cubed. Now I'm moving on. I have an x to the 5th power, sorry. So I'm going to put that in front, 4x to the 5th power. And now I'm moving on, so I've used that. I have my -11x, which will go next. And then I'm combining my 2 constants, a 7 and a -8, and I get -1. So this polynomial is the difference of these 2 polynomials. It has a degree of 5, and it has a leading coefficient of 4. And now for the final subtraction problem, we're going to rewrite that one as an addition problem by distributing again the negative to the second parentheses. So I'm going to rewrite the first set of parentheses, 4x squared plus 7x cubed y squared. Now I'm distributing the subtraction as a negative to each term in the second parentheses. So instead of -x squared, I'm going to write positive 6x squared. Instead of -7x cubed y squared, I'm going to have positive 7x cubed y squared. And instead of -4x, I'm going to have positive 4x. So now I'm looking for my highest degree term. This is a 2, this is a 5, this is a 2, a 5, and a 1. So it's definitely my 5, and they happen to be like terms because it's 3 x's and 2 y's. So if I have 7 of them, it's 7 of them. Altogether I have 14 x cubed y squareds. So that takes care of those. Now I'm going on to my next one, x squared and x squared, and I have 10 of those all together. And then finally I have my 4x. So the difference of these 2 polynomials is this trinomial has a degree of 5 and a leading coefficient of 14. So now you could go to Flipgrid and practice some of these on your own, and tomorrow you'll have practice form with adding and subtracting polynomials.